Good morning, students. Today we are talking about the fundamental physical quantities. Fundamental means the basic physical quantities, because if you keep on writing the quantities continuously, then there may be number of quantities. So that's why we have taken few basic physical quantities which can be multiplied or divided to get the rest of the quantities. So these seven fundamental quantities are length, mass, time, electric current, temperature, luminous intensity, and the quantity of matter. Length, that is the distance between the 2 points, and the SI unit is m, meter. Mass, it is the amount of matter present in the body, and the SI unit is kg. Time, the SI unit is second, this is the time. And the electric current, this is the amount of charge flowing per second, and the SI unit is ampere. Temperature, SI unit is Kelvin, this is the degree of hotness and the coldness. Luminous intensity, that how much bright the object is, and the SI unit is candela. Then the seventh one is the quantity of matter, that is how much matter is present. Again, this we will get confused with the mass. Mass is amount of matter, and this is again talking about the quantity of matter. So this is talking about that how much matter, that means that number of moles present in the substance. These are the seven quantities. On the basis of these seven quantities, we are going to derive all rest of the quantities. And for that, what we are going to do, we'll be talking about that the dimensions formulas. That is the dimension formula. There are seven fundamental quantities. The dimensions of the seven fundamental quantities: dimension of length is L, dimension of mass is m, dimensions are always written in the square brackets, dimensions of time is T, dimensions of the electric current is A, dimensions of temperature is K, and dimensions of luminous intensity is candela, dimensions of amount of substance, that is the quantity of matter, that is mole. Basically, we will be dealing about these three things, that is length, mass, and time. Now, what is this dimension means dimension means the number of ways we can define. So there are seven fundamental quantities based on which rest all the quantities can be defined. So we'll be talking about these quantities. Now, whenever we have to write about the physical quantities, so we'll be writing the dimension formula. So first you have to learn the dimension formula. The dimension area is equal to length into breadth. Length is L and breadth is again a distance, so dimension will be L. So L into L will be L square. So mass is 0, L is 2, and T is 0. SI unit will be m square. In this way we are going to write it. Volume will be length breadth into height. Length is L, breadth is again L, height is again L. So m, there is no m, so m raised to power 0. L, there are 3 times, so 3. T, there is no T, and most of the dimension formula you will be writing only these three basic one: mass, length, and time. Rest of the things, if it's required, then you need to mention it, otherwise it's not required. Density is mass upon volume. For finding the dimension formula, what you have to learn? You have to learn these small formulas. Okay, so density is equal to mass upon volume. Mass means m, and volume, already we have calculated the dimensions of volume, that is L cube. We can write either in form of m naught, L3 T naught, or we can simply write it as L cube also. So it will be m L minus 3 T. Whenever we are writing the dimension, the final answer should be in terms of this inside the square bracket. Similarly, speed, distance upon time, so L upon T, m0, L, T minus 1. Acceleration, we know that change in velocity upon time. Velocity or speed, just now we have calculated, that is L, T minus 1, and this time, so this is time, so the formula will be L, T minus 2. We have to write it inside the square bracket, so this is the final dimension formula. Momentum is mass into velocity. Mass is m and velocity just now we have calculated L t minus 1, and this is the momentum. Force also mass into acceleration. Acceleration we have calculated just now. So we'll write down the acceleration value of acceleration and m. So it will be m L t minus 2. Work is this, force into distance. Force just now we have calculated m L t minus 2. So distance is L, so for work will be m L square t minus 2, and work is equal to energy. So any kind of energy, any kind of work, the dimensions will be same. We have to learn these formulas because dimension is a very important topic.